Imagine holding a superpower in your hands, the ability to rearrange matter atom by atom. Sounds like something out of a Marvel movie, right? Well, that's not fiction anymore. Welcome to the world of nanotechnology, where science shrinks down to the tiniest scale and the impact is massive. Hi everyone, today we are diving into the fascinating world of nanotechnology. Don't worry though, I won't be throwing around heavy jargons. Think of this as story time, except the characters are atoms, molecules, and a whole lot of imagination. By the end, you'll see how this invisible world is shaping our very visible lives. Now, what does nano mean? Nano simply means 1 billionth of a meter. To put that in perspective, take a single human hair. Now imagine slicing it lengthwise into about 80,000 parts. That's the scale we are talking about. It's like zooming in so much that a skyscraper suddenly feels like a Lego block. Why the nanoscale is special? At the nanoscale, materials stop behaving like their larger selves. It's like your mild mannered friend suddenly turning into a superhero. Gold, for example, normally yellow glows red or purple at the nanoscale, thanks to quantum effects and the increased surface area. Think about crushing a candy bar into powder. More edges means more places to react, which makes nanoscale material stronger, faster, and more reactive. Visualizing the nanoscale. A red blood cell is around 7,000 nanometers. Viruses, just about 20 to 400 nanometers. That's like comparing a bus to a skateboard. And DNA, even smaller. At this scale, the rules of physics feel like they've been rewritten. No wonder scientists are obsessed. How does the matter behave differently? Carbon nanotubes, thinner than a strand of hair, are stronger than steel, but can bend like a gymnast. Nanoparticles can sneak inside your cell to deliver medicine right where it's needed, cutting down nasty side effects. It's like hiring an Uber that drops you directly at your destination instead of 3 blocks away. Now, nanotechnology in everyday life. Here's where it's getting exciting. Your smartphone owes its speed to thinness of the nanotech. Cancer treatment now uses nanoparticles to attack tumors like with sniper-like precision. Solar panels are doubling efficiency thanks to nanomaterials. So the next time you binge watch on your sleek phone while sitting under a rooftop solar panel, you are already living in the nanotech era. Environmental and industrial application. Nanotech isn't just cool, it's saving the planet. Imagine a filter so fine it can pluck bacteria and heavy metals out of water. That's nanofiltration. Or fabrics that resist stain, fights germs and never wrinkle. Goodbye ironing board. And lightweight nanocomposites make planes and car fuel efficient, cutting emissions. Basically, nanotech is like a Marie Kondo for industry, tidying up inefficiencies everywhere. Cutting edge examples. Some jaw dropping breakthroughs. Kyoto University created a semiconductor that doubles solar panel efficiency. Nanobiosensors sniff out pathogens in your food before they make you sick. Nanorobots are being tested for surgeries so precise surgeons may soon have assistants smaller than ants. And self assembling nanostructures. Yes, Lego blocks that build themselves are real. It feels like the future is already unpacking itself in front of us. The future of nanotechnology. The future, think nanotechnology teaming up with AI, gene editing, and 3D printing. That's like assembling the Avengers of science. Personalized medicine, smart materials, and clean energy are just the beginning. Of course, there's an ethical side. How do we balance innovation with safety? That's an ongoing conversation because with great nanopower comes great responsibility. Let's wrap this up. Nanotechnology is proof that small things can change the world. Like the universe whispering. Size doesn't define impact. From healing our bodies to powering our gadgets to cleaning our environment, nanotech is already shaping our tomorrow. And here's a thought to leave you with. If we can master the world at the scale of atoms, what's stopping us from reshaping our future at any scale? What does this mean for the future of humanity? And are we about to become the architect of reality itself? The future, my friend, is not just bright, it's tiny.